Welcome to our spatial learning video series, where we'll use the power of spatial computing technology to take learning to the next level. Wherever you are, we're excited to go beyond your TV, textbook, or computer screen and blend learning experiences into our physical world together.
Hey everybody, Alex here again, and today we're going to learn about outer space. Specifically, we're going to learn about our world, planet Earth, and our moon that orbits around us every day and every night. We're going to use the power of spatial computing from Magically and a great application called Universe Sandbox from Giant Army. We're going to take a look at Earth from the vantage point of an astronaut. And then, without having to leave our homes, we're going to fly on over to the moon. And we're going to get to check that out, just like astronauts in the past have done. And we're going to learn a little bit more about each of those surfaces together. I'm going to keep it a little bit darker here because, hey, that's just like outer space, a little bit darker. You guys ready? Let's go. And here we go. We can see planet Earth. Not from the ground like we usually do, but from outer space. Something's wrong though. It's not moving. What we know is that every day, every night, every moment, the Earth is spinning. Let's make it happen. There we go. Now we see the Earth spinning. We can see the water in blue all over. We can see different land masses in kind of a brownish tan. There's Asia passing by. There's Africa. There's South America and North America, where we live. Also, we've got these white specks in lots of places. What do we think that is? If any of you guys guessed clouds, you're right. Those are the clouds that come up from the ocean, turning from water into water vapor, and then rain down from time to time. This is what it would look like to be circling around the Earth from something like the International Space Station and getting to see it from up above. Pretty beautiful, huh? But we can also see way off in the distance is the moon. And that moon orbits around our Earth all the time. And we've actually visited the moon before, and we're going to visit it today through the power of spatial learning. But before we do, I just want us to learn a little bit more about the Earth. Let's get started. So we here have a little bit of a fact sheet about the Earth. We can see how much it weighs, or its mass, how big it is, or its radius, and a lot of other information, like its motion, how fast it's moving, how far it moves. We can also see its composition. Another word for composition is the stuff that makes up the Earth. It's land and the oceans, seas, and rivers. The big ones to think about are iron, silicate, water, and hydrogen. Now, let's move back up here, and I want us to focus on water, because there's a very delicate balance between the balance we see of water to land. Now, what would happen if there was more water than we have today? Because maybe in the Arctic up here, or the Antarctic down there, the ice caps started melting. Or if we had a lot of water come down from the clouds that we've seen. Let's explore what would happen if I add a little bit more water. Look what's happened. Most of the land that was here has now flooded. We can see little specks of it, but not a whole lot. most of the Earth is now totally covered with water. Look at this little speck here. That's all that's left. So I hope this gives you guys an appreciation for that balance. With just the right amount of water, we all stay well nutrition, and that there's water going throughout all of our systems. But if we have too much, it floods. Let's go back to a better balance. And there we go. We see the land back, just how it was, just how it ought to be. The next thing I want us to do is to really get into astronaut mode. And let's fly from the Earth all the way over to the moon. Now, where is the moon? There it is. Let's go. Boom. And now we're at the moon. And we can see it just like astronauts did when they visited. We can see different craters. Those are some of the darker spots. We can see it from the bottom. We can see it at the top. It's a lot smaller than the Earth, no? Now, just how much smaller? Let's learn about it and see what it is. Bring our fact table a little bit closer for us. And one thing that I want us to focus on is the mass, how much it weighs. Now, this is a big number right here, but if we compare it to the Earth, because it's less than 1, that means that it would take many, many more moons put together to equal the weight of one Earth. Specifically, it would mean that we need almost 100 moons all together to equal the size in weight of the Earth. Pretty amazing, huh? And the last thing that we'll do is take a look at the Earth from the moon. Now, where is that? There it is. I'm going to walk over here so we can get a sense of the Earth and the moon together. Now, when we looked out from the Earth at the moon seems super, super tiny. But when we're looking at the Earth from the moon, the other direction, the Earth actually looks a little bit bigger. And this is what it would be like to be right around the moon as an astronaut, looking back at the Earth. Pretty wild stuff, huh? Gonna move it out of the way over here. And we're gonna wrap up thinking about what we've just experienced. We got to see the Earth from outside in outer space, got to explore what it would be like with more water versus less water, got to learn about how much both the Earth and the moon weighs, and got to pretend like we were astronauts, flying all the way to the moon and then looking back at good old planet Earth. That's all for now. Hope you guys enjoyed this spatial learning adventure. See you next time.